And then we can begin. All right. So compositions. So basically we learned about compositions yesterday. And just a reminder that compositions is basically applying two or more transformations in a sequence. So instead of just one transformation occurring, we can have multiple transformations occurring. That can be a rotation and a reflection, a translation and a rotation and a reflection. So just multiple transformations happening. And what we learned is that we read compositions from the right to the left. So the rightmost transformation is applied first, and then the leftmost. So that was the big takeaway yesterday. So let's go ahead and look at some example problems. This one asks, what is the final transformation in the composition of transformation that maps the pre-image ABCD to image A double prime B double prime C double prime and D double prime? So basically we're looking for what is the final transformation. Well, there's some key things we need to remember here. The first is that the pre-image does not contain the prime notation. So this is where we start because it doesn't contain the prime notation. The next thing is that what we learned yesterday is that if we see one prime notation, then that is our image after one transformation. If we see two prime notations, then that is our image after the second transformation, right? So the first one comes first and then the second one. So if we're being asked, what is the final transformation? What we're essentially being asked is, how did we get here? How do we get from 1 to 2? Because the final one would be the second one, the second image after our last transformation. And so what we'll see here is that the orientation changes. So we actually do not have a translation because the orientation changed, right? The location or the way in which the trapezoid is present is different. And now we want to determine, okay, do we have a rotation? Yes. Do we have a rotation 270 degrees or 180 degrees? Well, if we were to have a rotation 180, what that would actually look like is this trapezoid would actually appear to be something like this. And that's not what we're getting, so we can do away with that. So we do know we have a rotation. And we know now that it's not 180 degrees, so that leaves us with a 270 degree rotation. Okay? And if we wanted to identify all the different transformations, we could do that as well. Like we could say, how does this get from here to here? Well, it looks like we slid the pre-image to image 1. And so I would say that's a type of translation. And then after image 1 to image 2, we just concluded that we actually have a rotation of 270 degrees. That means the first transformation would be the translation, and then the final transformation or the second one would be that rotation. Okay? Any questions about this? Questions, concerns? Okay. Let's look at this next problem. This one's very similar. And it basically says a composition of transformations maps triangle XYZ to X double prime, Y double prime, and Z double prime. So we start with our pre-image, that without the prime notation. Our image 1 is that with only one prime notation, and then our second image would be that with 2. And here we see 1, 1, here we see 2, and 2. Okay? So this asks, the first transformation for this composition is, so we're looking for what is the first transformation, and it's already telling us the second transformation is a 90-degree rotation about point X. So how do we get our first transformation? So how do we get from the pre-image to our first image after our first transformation? That's what that 1 represents. Well, is it a rotation? It doesn't actually look like a rotation. So is it a translation to the right? Well, if we translated it to the right, then what is this line right here, right? So not a translation. Is a reflection across line M? Well, M is in fact our line of reflection. And because we see that line, we know we have to have some type of reflection. And so therefore, D is in fact our answer. D is the first transformation that's taking place. For the second one, here it's telling us is a rotation 90 degrees. Okay. Any questions about this? questions? And this one you need to be able to differentiate between your first image after your first rotation and your second image after your second rotation. That's why it's important to remember. If you see 1' notation, that's after your first transformation. And if you see 2, then that is your image after your second or final transformation. If you have 2 only. Okay. Any questions about this? Okay. Here is the next problem we might encounter. And this one basically says the rule. So we're given a composition is applied to our pre-image ABC. The triangle shows the final image. So here we have our composition. We know this is a composition because we see this symbol right here. And we know we read compositions from right to left. So this one would be first. This one would be second. The first one would be a rotation about the origin 90 degrees. And then the second one would be a reflection across the x-axis, or the y-axis, sorry. And so what I need to do or be able to do is translate my pre-image, these coordinates right here, given these different transformations, and find out where it ends up. So our rule for rotation 90 degrees is we take the original coordinates and we negate y and then switch x and y. Our reflection for our rule for reflection across the y-axis is take the original coordinates. You just negate the x. So we're going to start with our pre-image coordinates. Our pre-image is located, put it right here. A is located at 2 and 4. Oh, sorry. 2 and -4. B is located at 4 and -4. C is located at 4 and -2. Okay, so that's where my pre-image is. Now I want to do my first transformation, which is going to be my rotation. What do I need to do? First thing I need to do is negate the y and then switch them. So 4, 2, 4, 4, 2, 4. Okay, so that's the first thing. Now I want to apply my second transformation. So I need to negate the x. So it becomes -4, 2, -4, 4, and -2, 4. And so now I want to see where that image is. So -4, 2. This would be my A double prime. -4, 4. This would be my B double prime. And -2, 4. This would be my C double prime. So that tells me that my resulting image is right here, which is figure 1. And so that's what I would select. So basically what I'm doing here is I'm taking my original coordinates and applying these mapping rules in the order that they need to be from right to left. And I apply the first transformation to this set of coordinates and then my second transformation to this set of coordinates. So basically, I'm just applying multiple transformations to my sets of coordinates to find out where I end up. Okay. Any questions about this? And sometimes you may have to find all the coordinates, but sometimes you may be asked to identify a specific coordinate. So you don't have to necessarily spend time doing all of them. Like this one, again, here we have the rule. This is our composition. It's applied to our pre-image FGH to produce F double prime, G double prime, H double prime, or the coordinates of vertex F double prime. So basically, all I need to work with is F. So I start here. This F is located at 1 and 1. And basically what I'm just going to do is I'm going to apply both of these transformations from right to left to my original F. The first thing is a rotation 180 degrees, which tells me to take my original coordinates and negate them. So I can do that. negate, negate, that gives me f prime at -1 and -1. Okay? Okay. Now I want to apply my second transformation, which tells me to add 5 to x and subtract 0.5 from y. So if I add 5 to x, subtract 0.5 from y, adding 5, so -1 plus 5 is 4. -1 minus 0.5 is -1.5. So that means my f double prime is at 4 and -1.5, which is answer choice A. So in this instance, I'm not having to map all the coordinates. I only need to map my f. I apply my first transformation here, and then my second transformation there, giving me where my resulting f double prime is, which would be at 4 and -1.5. Okay, any questions about this? So these are the different types of problems you might encounter. You might just work with one vertex. You might work with all the vertices. You might just be asked to identify what transformation is taking place, the first transformation or the final transformation. These are the different types of problems you might see. Okay. Any questions? Okay. If there's no other questions, you guys may